In this section, we're going to learn about the 68, 95, 99.7 rule for normal distributions. So we saw in the last section that a normal distribution is completely determined by its mean and standard deviation. So in particular, all normal distributions are the same in terms of what proportion of observations are within any given number of standard deviations of the mean. So let's take a look at what this means. So this gives us the 68, 95, 99.7 rule. And according to this rule, if you have a normal distribution, then about 68% of the observations fall within one standard deviation of the mean. 95% of the observations fall within two standard deviations of the mean. And 99.7% of the observations fall within three standard deviations of the mean. So there's a nice chart in your book, and I've copied it here on the slide. So this just shows graphically what the 68, 95, 99.7 rule says, and this is helpful if we're looking at an interval in terms of standard deviations and we want to see what percent of the observations are within that range. Then we can just look at this handy little chart and figure that out. So let's look at an example. We also saw in the last section this graph for the heights of American women, and we found that this distribution has a mean of 64.5 inches and a standard deviation of 2.5 inches. So let's apply the 68, 95, 99.7 rule and see what we can find out about this chart. So how far is one standard deviation from the mean? That will be 64.5 minus 2.5 is 62 inches is one standard deviation to the left of the mean here. And then 64.5 plus 2.5 is 67 inches is one standard deviation to the right of the mean there. So by our rule, 68% of women are between 62 and 67 inches tall. So that's one standard deviation. For two standard deviations, we do the same thing, except now we're looking for how far away two standard deviations is. So 2 times 2.5. So that will be 64.5 minus 5, which is 59.5 inches. And then 64.5 plus 5 is two standard deviations to the right, and that will be 69.5 inches. So by our rule, 95% are between 59.5 and 69.5 inches. And finally, for three standard deviations, that's going to be 64.5 minus 3 times 2.5 is 57 inches, and 64.5 plus 3 times 2.5 is 72 inches. So that means I'll go up here that 99.7% of women are between 57 and 72 inches tall. Alright, so that's applying my 68, 95, 99.7 rule. This is what I found. So that's that example. Let's take a look at one more example. So here we've got we're looking at the SAT reasoning test scores. And the distribution of scores on tests such as the SAT is close to normal, so we can approximate it with a normal curve. And scores on each section of the SAT are adjusted so that the mean score is about 500 and the standard deviation is about 100. So given this information, how high must a student score be to fall into the top 25%? So remember, if I have my normal curve like this, then the quartiles, Q1 and Q3, I've got 50% of my students falling between the two quartiles. So that means I must have 25% either above or below that, since these are symmetric. So to fall into the top 25%, a student has to score at least whatever the third quartile is. And we know that that is 2/3 of a standard deviation away from the mean, so that will be the mean, 500, plus 2/3 of a standard deviation, which is 100. And that will give me 567 as the score that a student has to get to be in the top 25%. What percent of scores fall between 200 and 800? So let's draw my curve again here. My mean is at 500, and then 800 is up here, and 200 is down here. So what's the distance away from my mean of those 2 points? Well, 800 minus 500 is 300, which is 3 standard deviations. And then for 200, 500 minus 200 is 300, so that's also 3 standard deviations away from the mean in the opposite direction. So according to my rule, everything within 3 standard deviations is this whole area in here, and that's going to be 99.7% of scores fall into that range. Finally, one more question. What percent of scores are above 700? So since our mean is 500 and our standard deviation is 100, 700 is 2 standard deviations above the mean. And we know that the area within 2 standard deviations of the mean is 95%, so that we've got 5% that lies outside of that. 2.5% is going to be below 2 standard deviations away, which is 300, and another 2.5% is going to be above 700, which is 2 standard deviations away. So that's going to be 2.5% of scores are above 700. So that's the end of this section. It's pretty short. What you should know for this section is how to use the 68, 95, 99.7 rule to find selected areas under a normal curve.